Here we're going to talk about consumer and producer surplus. So starting with this consumer surplus, we are typically consumers when we're talking about buying stuff, like we're used to buying stuff instead of being the seller. So when we're talking about consumer surplus, that's what we feel like we're saving. So thinking just in terms of real life first before we put a complicated integral formula next to it, when we buy anything, there's an amount we're willing to pay. So you have the amount you're willing to pay. So something I buy every year are like new workout shoes because I lift most days in a week and I want to make sure that I have shoes that are comfortable. And normally I'm willing to spend around $120 maybe for a nice pair of workout shoes. So I go into the store thinking, hey, I'm buying new workout shoes. I'm willing to pay $120, but then that doesn't always match up with the amount that I actually pay. So you have the amount you actually pay. So sometimes I find a shoe that I like and it's on clearance for $100. So I walk out of there feeling like I saved some money. So I have an amount that you feel like you saved. So in my example that I just made up, I was willing to pay $120 for a nice pair of workout shoes, and what I actually paid was $100. So I feel pretty good. The amount I feel like I saved is $20. There's my consumer surplus. So thinking about that from an actual mathematical standpoint, when we think about consumer surplus, we're thinking about the shape of a demand function. So I'm going to draw a general demand curve. This is typically what it looks like. If you have your x-axis, this is X, which is the quantity sold. And that's dependent on P, the price. So you have your market price. So as price is higher, the demand is smaller. You're going to have a lower X value. It's going to be more toward the left. As the price goes down, the demand is going to get bigger and it's going to go further out to the right, have bigger X values. So if we draw in a general shape of a demand function, it would look like this. Here's our demand. As price is high, up here there's less demand, the X value is smaller. As price goes down, the demand gets bigger, and then it kind of tapers out at some point because not everybody wants to buy a new pair of workout shoes, like this example. You can be selling something that only a certain number of people are interested in no matter what. So then we have something called market equilibrium, which is found by setting demand and supply equal. So I haven't drawn a supply equation yet, but we're going to get this thing called market equilibrium. And so that's really the amount that you actually end up paying. So we actually end up paying that P determined by the market equilibrium, but we were willing to pay that higher amount determined by the demand function. So we get kind of this shape here where our consumer surplus is this part. So how we would find how much consumer surplus we have is we would say consumer surplus CS is equal to, well, it's going to be the area under that curve from 0 to X bar of the demand function. So that would tell us the whole entire area under the curve. We don't want that whole entire area because we don't want this box in here. We want just the amount that we feel like we saved. So we're going to subtract out the area of that box. Subtract out X bar times P bar. That way, when we think about this picture, that integral from 0 to X bar measures this whole integral, but then we've subtracted out that area of the box, X bar times P bar, to give us the amount that we feel like saved. So if we compare that on the other end, there's a producer looking at this, and on their end, they have the amount that we actually paid. So we have the amount the producer receives. So in this example, they received $100 for my workout shoes, but I'm feeling good. I feel like I saved $20. But they have the amount they received, and then we can subtract out. They had a minimum amount the producer would accept. So I'm over here feeling good, feeling like I saved $20, but then when they look at their charts, they're like, hey, you know what, we just got $100 for selling this pair of workout shoes, and the minimum amount that we would have been willing to receive for those shoes is $60. So they're still sitting pretty. I feel like I got a deal because I spent $100 and I was expecting to spend around $120, but on their end, they're still sitting pretty. They sold it for $60 above the minimum amount that they could have accepted for the shoes. So sometimes these are the same number. Sometimes the producer and consumer surplus are both $20 or are both $60. But ideally, when these companies are looking at this and making their sales, they always try to come out better. So it kind of makes sense that in this example, they may have been able to take it for $60, which sometimes you can find shoes on super clearance, but... Now we're going to see what that looks like graphically. So from a supply end, supply is what the producers are concerned about. So we need a supply equation instead of a demand equation. Lots of things going on with surplus here. So if you think about supply is what they have sitting in stock. As price goes up, so does the supply. There's more supply sitting in stock, less people are buying it. It's not flying off of the shelf. So we still have our X and P, same labels as before. We would still have our market equilibrium, which is again determined by where supply and demand cross. We'll see that in a second. So here's our market equilibrium point. I'll put in there X bar and P bar. So we paid above the amount that the supplier actually needed. So we paid this much above the minimum amount that they would have received. So there's our box for this one, and the producer surplus would be right here. They had a sale price of $100, and that was above what they were willing to take as a minimum, so they get some surplus in there. Definitely not drawn to scale to show 20 compared to 60, but this is just a general example. And how we find that from an integral is we would say, well, first we have the area of this big box. So we would take the integral from 0 to X bar of the supply equation to find the area of that box. And then we would subtract out, or subtract that from, rather. And move this over. We need to subtract that from the big box. So X bar times P bar. The order switches because we have this whole big box and we want to remove the area under the curve. So we're going to take X bar, P bar, and we're going to subtract the supply equation from it. So a common question is, why does the order change? And the reason is because graphically you would see that the order changes. So if you had to erase and make some changes, that will help remind you that the order is different. And the reason is the pictures are different. So the last piece in this before we get into some real life examples and see that it's not too bad compared to this whole big explanation. The integrals are basic integrals, which is not too bad. But the last thing we need to figure out is, where does this market equilibrium come from? So it comes from finding where a demand function intersects with a supply function. That's where that X bar, P bar comes from, is where they intersect. So graphically we can see how they would intersect here, and we would call this point market equilibrium. So we're going to look at finding consumer and producer surplus. One thing to keep in mind is this is cumulative consumer surplus. So I feel like I saved $20 that week that something is on clearance, but so does everybody else. That consumer surplus is going to be a huge number. It's going to depend on how many they're selling in total. And then same thing with producer surplus. It's going to be more than just that $60 that they got extra from me. It's going to be extra from everybody that bought the shoes above $60. So we're going to get some pretty big answers because it's considering all of the things sold or purchased.